Is it visible? Anyone?
Yes,
Anyone?
sir.
Okay. Good evening, students. Today I'm going to discuss about pile foundations. In geotechnical, we have two types of foundations. One is a shallow foundation. Second one is a deep foundation. So shallow foundation means according to Terjagi, if the depth of the foundation is less than the depth of the foundation, it is called as shallow foundation. So we need to compare breadth of the foundation and depth of the foundation. If the breadth of the foundation is less than depth of the foundation, it is called as shallow foundation. If breadth of the foundation is the breadth of the foundation is greater than pile foundation depth of the foundation, breadth of the foundation greater than depth of the foundation, it is called as shallow foundation. If the breadth of the foundation is less than depth of the foundation, it is called deep foundation. So once again I repeat, breadth of the foundation and depth of the foundation. If the breadth of the foundation is greater than depth of the foundation, it is called as shallow foundation. If breadth of the foundation is less than depth of the foundation, it is called as deep foundation. The pile foundations comes under the category of deep foundation because the depth of the foundation is greater than breadth of the foundation. So let me ask you what do you mean by pile? So a pile is a slender structural member. It is made up of concrete, steel, wood, or composite material. So a pile is either driven into the soil or formed inside by excavating a hole and filling it with the concrete. So generally we have two types of constructions. One is cast in situ, another one is precast. Precast means the pile is manufactured in factories and it is transported to the site. Then it is driven into the soil. It is called as a precast concrete pile. Or sometimes a borehole is made and a borehole is filled with concrete and steel. Then pile is formed. It is called as cast in situ. If pile is manufactured outside, it is called as cast in situ. Otherwise, if the pile is manufactured in factory and it is transferred to site and it is driven to the soil, it is called as precast concrete pile. The pile is a structure member which transfers the load coming from the superstructure to a hard strata through the weak soil. That means it bypasses the weak soil. So generally, you foundation is located in weak soil. What will happen? It causes shear failure or it may cause a huge settlement. So that's why the foundation is not located in the weak soil. So the pile is taken to the hard stratum, up to the hard stratum. Then it transfers the load coming from the building to the hard stratum, not in the weak soil. It bypasses the weak soil. That is the main function of pile. So a pile transfers the load coming from superstructure to the hard stratum through the weak soil. It bypasses the weak soil. The pile foundation is a type of deep foundation in which loads are taken to a lower level by means of vertical members, which may be timber, concrete, steel. So this is the uh, material used for manufacturing of pile foundation. So we can use the timber as a pile foundation, or concrete as a pile foundation, or sometimes we can use steel as a manufacturing of pile foundation. So uses of pile. So the load of the superstructure is heavy and its distribution is uneven. So when the heavy loads are need to be transferred to the soil, then we can go for pile foundation. At the same time, some it is the load is uneven. In some columns, heavy loads are coming. In some columns, only light loads are coming. In such a case, the load distribution is uneven. In such a case, we can go for pile foundations. Second one is the topsoil has poor bearing capacity. The topsoil cannot take the heavy loads. In such a case, the pile transfers the load to the hard strata by bypassing the weak soil. The third one is the subsoil water is high, so that pumping of water from the open trenches for shallow foundation is difficult and economical. Suppose if the water is present up to the ground surface, so we need to dewater the dewater should be done to remove the water from the soil during the excavation. But sometimes it is not possible to dewater from the foundation. In such a case, we can go for pile foundations, which can take the load to the hard stratum through the water table. The next one is large fluctuation in subsoil water level. So fluctuation means change in water level. So there is a frequent change in water level. Water level is not constant. Sometimes it may rise to the ground surface, immediately it may to go down. In such a case, the bearing capacity may be reduced because of this presence of water table. That's why piles are used to transfer the load to the hard stratum through the weak soil. So the structure is situated on a seashore and river bed where there is a danger of scoring action of water. Then we can go for pile foundation. So all offshore structures or seashore structures are made with the pile foundations. The canal or deep shrinkage line exists near the foundation. So if a canal or a drainage is exist near the foundation, then we can go for pile foundations. So for foundation or transmission towers and offshore platforms, which are subjected to uplift forces. So in the case of transmission powers and also offshore platforms, because of presence of water below the structures, it causes uplift pressure so that they may be lifted upwards. In such a case, pile foundations are used to resist these horizontal uplift forces. You can see the transmission power and scouring and offshore platforms. Here we need to go for pile foundations instead of shallow foundations. The factors affecting selection of type of piles. So the type of piles depends. The selection of type of pile depends upon the following factors: nature and type of structure, location, material, equipment, and fund availability, type of soil and its properties, groundwater table, durability of pile, length and number of piles, case study of adjacent buildings, facility for pile driving, erosion of soil near the structure. So sometimes we need to go for steel foundation. Sometimes we need to go for concrete pile foundation. Sometimes we can use timber as a piles. In such a case, we need to select depending upon the situation. We can select the type of pile. So the selection depends upon these following factors. The classification of piles. So piles are classified into three types. So based on function, based on materials, and based on method of installation. So based on function, so we have end bearing pile, friction pile, both end bearing and friction pile, compaction pile, tension pile, anchor pile, fender pile, batter pile, and a sheet pile. So for every pile, there is a function. Then it can fulfill an objective. So based on the function or objective, piles are classified like this. So end bearing pile means the pile painted through the soft soil, bottom or tips rest on the hard stratum. So the entire load is taken by the bottom tip of the pile. So because the bottom of the pile rests on the hard stratum, when load is applied on the pile, the entire load is transferred through the bottom tip, not by the not by the soil. So entire load applied on the pile is transferred through the bottom tip of the pile. The friction pile is here. The pile should not extend to a great depth. The pile are driven at a depth where friction resistance will be equal to load. So the entire load that is applied on the pile is resisted only by the friction between the soil and pile. So pile consists of soil around it. So there is a friction between pile and soil. When load is applied, that load is transferred to the soil through this friction. So such a pile is known as friction pile. So in the case of end bearing pile, the load is transferred through the bottom tip of the pile foundation. In the case of friction pile, so in the case of bearing pile, the pile penetrates through the soft soil up to the bearing strata. But in the case of friction pile, the pile does not extend to a great depth. It is not rest on the hard stratum. So the load applied on the pile is taken by the friction between the soil and pile. So the total friction resistance can be increased by increasing the length and diameter. So making pile surface rough, placing closely or grouping of the pile. So by increasing the length of the length and diameter, we can increase the friction between the soil and pile, and making pile surface rough. We can also increase the friction by placing closely or grouping of the pile. Also, we can increase the friction between the soil and the pile. That's why the load applied on the pile is taken by only the friction, not by the bearing. So we have one more pile, both end bearing and friction pile. That means the load applied on the pile can be taken by bottom tip of the pile as well as friction between the soil and the pile. So the load transferred is taken by bottom tip of the pile, known as end bearing, and as well as the load is taken by friction between the soil and the pile. So this is not a friction. So sometimes the pile can transfer the load through the friction as well as bottom tip. Such type of piles are known as both the end bearing and friction pile. The compaction pile is the object of the pile is sometimes the soil may be in loose condition naturally. In such a case, in order to increase the density of the soil mass, a pile is driven by means of hammering blows. So while driving the pile, vibrations are created around the pile. Because of these vibrations, the soil is densified. The soil comes too close to each other, so the density of the soil mass increases. So by increasing the density, we can also increase the bearing capacity of the soil. So the objective or function of compaction pile is to increase the density of the soil mass and also load carrying capacity of the soil mass. Here the pile cannot carry any load. So just it increases the bearing capacity, load carrying capacity of the soil. So and one more pile is a tension pile. When structure subjected to uplift due to hydrostatic pressure or overturning movement, in such a case, in order to resist the uplift force exerted by the water, we can go for tensile pile. Here the piles are subjected to tensile force. That's why it is called as tension pile. So it is also called as uplift pile. So in order to resist the uplift force exerted by the water, we can adopt tension piles. So it is subjected to tensile force. That's why it is called as tension pile. It resists the uplift force exerted by the water. That's why it is called as uplift pile. So another pile is anchor pile. The objective of anchor pile is to anchor the ships and boats. So after reaching the destination, the ships and boats are anchored to a pile. That pile is known as anchor pile. So these are provided to anchorage against the horizontal pull from sheet pulling or any other pulling. So after reaching the destination, docks and harbors, after reaching the destination, the boats are anchored to the some piles. Otherwise, it may move along with the waves. Again, it will uh, try, it will move towards the seaside. In order to stop that, the ships and boats are anchored to the pile. Such a pile is known as anchor pile. The fender pile means, so these are used to protect the waterfront structures against impact from ships or other floating objects. So whenever the structure is subjected to floating objects or any other ships and boats, so the front face of the waterfront structures may be damaged. So in order to uh, protect the waterfront structures against the impact of ships or other floating objects, fender piles are used. You can see in the image. So batter pile. So they are used for resist the large horizontal forces or inclined forces. So in order to resist the large horizontal forces or inclined forces, batter piles are used. So sheet piles. So these are used as a bulkheads or impervious cutoff, reduce the seepage and uplift under hydraulic structures. So generally, in order to construct the bridges or piers in sea or oceans, we need to remove the water. So in order to remove the water, we need to go for sheet piles. So a well is constructed by means of sheet pile. Then the water in the well is dewatered. So that the place around the place surrounded by the sheet pile will become dry. Then we can go for foundations and also we can construct the piers. So it is also called as coffer dams. So coffer dams are meant for uh, laying foundations in the case of seas or oceans. So in such a case, we need to go for sheet pile. Sheet pile impervious material. It cannot allow the water to flow through it. So that's why first is where the place where we need to go for foundation, that place is surrounded by sheet piles. Then the water within the sheet pile is removed. Then we can go for foundations below the seas or oceans. So such a piles are known as sheet piles. So sheet pile is again classified as concrete sheet pile, steel sheet pile, and timber sheet pile, depending upon the material. So they may be concrete, steel, or timber. So classification of piles based on pile material. So they may be classified as concrete pile, steel pile, timber piles, composite pile, and sand pile. So concrete piles again divided into three types: precast piles, cast in situ, or pre-stressed. So precast means the pile is manufactured in factories and transferred to the site, then it is driven into the soil. They are known as precast piles. So cast in situ means a borehole is made in the a borehole is made at the site, then reinforcement is placed within the borehole, then it is filled with concrete. So a pile is made like that. So such type of pile is known as cast in situ pile. So pre-stressed concrete pile. Pre-stressed means stressing of the generally the reinforcements are stressed before the construction of a pile. That means they are elongated. Tensile force is applied before it is placed in the piles. So they are known as pre-stressed. By pre-stressing, we can enhance the tensile capacity of the pile. Such piles are known as pre-stressed. So sometimes it may be post-stressed because after construction of the pile, they may be stretched by means of by applying external forces. It is known as post-tension. The pre-stressed means before the construction, we will stretch the tensile rods. So post-tension means after construction of the pile, we can stretch the steel reinforcement. They are known as post-tensioning. Precast. So it is those which are manufactured in factory or at a place away from the construction site and then driven into the ground at the place required. It requires heavy pile driving machinery. It may be square, octagonal, or circular in cross section. The size of the pile vary from 30 centimeters to 50 centimeters in cross section and up to 20 meters or more length. The grade of concrete used to precast concrete pile is M20 grade concrete. That is 1:1/3 proportions. The cast in situ means a borehole is dug into the ground by inserting a casing. So borehole is filled with cement concrete after placing reinforcement. So the casing is kept in position or it may be withdrawn. So the piles with casing are known as cast in situ concrete pile. The piles without casing are known as uncased cast in situ concrete pile. So steel piles. So commonly used steel piles are H piles, box piles, and tube piles. So H pile means these piles are usually of wide plan sections. They are suitable for terrestrial type. That means like just like a table. So table has four legs. Terrestrial type also means it means four legs. So the structure which are resting on four legs are known as terrestrial type structures. So they are suitable for terrestrial type structure in which pile extend above the ground level and act as a column. So they have a small cross sectional area. So therefore they can be easily driven into the soil. So it is used as a long pile with high bearing capacity. That is the use of H piles. So advantages piles. So they can enhance the bearing capacity of the pile. So box piles. So they are rectangular or octagonal in the form filled with the concrete. So these piles are used when not possible to drive H piles into the hard strata. So sometimes because of hard soil, so the H piles cannot be driven to the ground. So in such a case, we can go for these box piles. So tubes or piles of steel are driven to the ground. So concrete is filled inside the tube piles. Because of circular cross section, tube piles are easy to handle and easy to drive in. So tubes are inserted to the ground. Then the tubes are filled with cement concrete after placing the reinforcement. Timber piles. So these piles are prepared from trunks of trees. They may be circular or square. So diameter of pile are 30 to 50 centimeters and length not exceeding 20 times its top width. At bottom, a cast iron shoe is provided and at the top steel plate is fixed. You can see in the image, the bottom of the pile is the bottom of the pile has cast iron shoe. So because the timber is submerged in water, so it may be attacked by interaction with the water. That's why the bottom of the pile is made with the cast iron shoe. So group piles, each pile is brought at the same level and concrete is provided to have a common platform. So generally a single column requires a minimum 3 number of piles. So after driving three or more number of piles, they are connected by a pile cap. So over the pile cap, we can construct the foundation. Composite pile means more than two materials. So more than one material. So this type of construction in which piles are two different materials driven one over the other. So they act together to perform the function of a single pile. So in this pile, advantage taken of durability of concrete piles and the cheapest of timber pile. So timber pile is terminated just at the level of the groundwater table. Sometimes we can use concrete and timber pile. Sometimes we can use steel and timber pile. Sometimes we can use concrete and steel pile, like that. Composite pile means more than one material, two different materials, or more than two different materials, a pile is made. Sometimes we can go for steel, timber, and concrete also. So such type of piles are known as composite piles. So in order to overcome the disadvantage of timber pile, we need to cover it with concrete or steel. So that's why we can go for composite pile. And also, in order to achieve the economy also, we can go for composite piles. In order to increase the capacity of the pile also, we can go for composite piles. Sand piles. These piles are found making a hole in the ground and filled with the sand and well rammed. So the sand to be used should be moist at the time of placing. Borehole diameter usually 30 centimeters. Length of sand pile is kept about 12 times its diameter. The top of sand pile is filled with the concrete. Sand piles are placed at 2 to 3 meters spacing. Load test should be carried out determining the bearing capacity of sand pile. The properly compact sand pile can carry load up to 100 tons per meter square or more. So in the case of weak soil, a borehole is made. That borehole is filled with sand. So for sand also we have some IS code specifications. So depending upon the IS code specifications, as per the IS code specifications, we need to use the sand. So after making the pile, the top of the pile, sand pile is closed with the concrete cap. So analysis of pile foundation. So till now I have discussed about the theory of pile foundations. Now I am going to take the analysis of capacity of the pile foundations. So already I discussed what you mean by pile foundation. So pile foundation means a structural member which can transfer the load coming from superstructure to this hard soil through a weak stratum. It is known as pile foundations. So the depth of the foundation is greater than breadth of the foundation. You can see here a column is there just like a column. So pile and a column both are similar, but a huge difference is there. In the case of column, no lateral support, but in the case of pile, lateral support is there in the form of soil, because the pile is surrounded by soil. That's why it has a lateral support. But in the case of column, there is no lateral support. So depth of the foundation is greater than breadth of the foundation. So here the load carrying capacity of the pile is defined as the maximum load carried by the pile without failure is known as ultimate load carrying capacity of the pile. So the maximum load, so more than that it cannot be. The maximum load carried by the pile without failure is known as ultimate load carrying capacity of the pile. It is indicated by QE. So estimation of ultimate load carrying capacity. So we have four methods to determine the ultimate load carrying capacity of the pile. Static methods, dynamic methods, penetration test, pile load test. So static method. First I am taking the static methods. The static method is used to estimation of ultimate load bearing capacity in clayey soil and also in cohesionless soil and also group capacity of the pile and negative skin friction. So static method is used to estimate the ultimate bearing capacity of the pile in clayey soil and cohesionless soil. At the same time, it can be also used to determine the group capacity of a pile. So pile capacity when it is acts as a single, and pile capacity when we take a group of piles. So more than one pile, if we take, it acts as a group. So as a group, also we need to find out the capacity of the pile, group capacity of the pile. At the same time, negative skin friction. Generally, skin friction is in upward direction, but sometimes in some situations, the skin friction to be towards downward direction. So the skin friction downward direction is very dangerous. It is called as negative skin friction. The static method also used to estimate the negative skin friction of the pile. So here I am going to explain the how to calculate the pile capacity in cohesive soil. So here I am taking both end bearing and also friction pile. So when load is applied on the pile, the load is taken by both end bearing and also friction. So that's why the ultimate load carrying capacity of the pile equal to load shared by bottom tip of the pile and load shared by skin friction. Qu is equal to Qb plus Qs. Qu equal to ultimate load carrying capacity, Qb equal to N bearing resistance and Qs equal to skin friction. So Qb equal to AB into Fb. So here N bearing resistance, it is a load. Load means, so stress is equal to load by area. Load equal to stress into area. Here I need stress. Stress is equal to load into area. So area here I am taking the bottom tip of the pile foundation. That's why area of the bottom AB is known as area of the bottom of the pile AB. FB is known as bearing capacity of the soil at the bottom of the foundation. So bearing capacity means pressure. Here I need load taken by bottom tip of the pile. Load equal to area into pressure. Area means area of the bottom of the pile. FB means bearing capacity of the soil at the base of the or bottom of the pile. So QB equal to area of the bottom is known as pi d square by 4. For a circular pile, it is pi d square by 4 into CNC. CNC for bearing capacity of the soil at the base. C is known as cohesion of the soil. NC is known as bearing capacity factor. Generally, for clayey soil, it is taken as 9. It is not given in the problem. By default, NC is equal to 9 for clayey soil. C is known as cohesion. It is half of unconfined compressive strength. If unconfined compressive strength is given in the problem, cohesion equal to half of unconfined compressive strength. So D is known as diameter of the pile at the bottom. So pi d square by 4 will give the area of the pile at the bottom. CNC will give the bearing capacity of the soil at the base. So the first term is over. So ultimate bearing capacity, that means load applied on the pile is shared by bottom tip of the pile and also skin friction between the soil and the pile. So bottom tip of the pile, the load taken by bottom tip of the pile or end bearing resistance is equal to AB into FB. AB equal to area of the pile at the bottom, pi d square by 4 into FB equal to bearing capacity of soil at the base, C into NC. C is known as cohesion of the soil, NC is known as a bearing capacity factor. For clay soil, it is 9. So AB equal to pi d square by 4, diameter of the pile at the base. FB equal to C into NC. So already, so for clay soil, NC equal to 9, it is a standard. For cohesionless soils only, it varies. So for sandy soils, NC is not constant. NC may be varies. It may be sometimes 8, it may be sometimes 12, it may be 20, like that. It may varies depending upon the type of cohesionless soil. But for clay soils, it is a standard value, NC is equal to 9. So next QS, so second term. QS is known as skin friction. The skin friction. Here also the load taken by skin friction. So load equal to area into pressure. Area equal to surface area of the pile. Here friction develops between the surface of the pile and surrounding soil. That's why AS is known as surface area of the pile. So for circular, it is a pi d into L. For square, it is a 4b into L. For rectangular, it is 2L in plus 2L plus 2b into L. Surface area. AS is known as surface area. So FS is known as shear strength of the soil at pile surface. shear strength of the soil at the pile surface, average undrained cohesion. So alpha equal to shear mobilization factor or adhesion factor. So alpha equal to 1 for soft soil, that is assumed that complete contact of pile with the soil. So in the case of soft soil, if a pile is driven into the soil, there will be some complete contact between the pile and the soil. So that's why alpha is taken as 1. So in the case of stiff soil, there will not be any complete contact. There will be some gaps between the pile and the surrounding soil. So it is assumed that partial contact of the pile with the soil. That's why alpha is less than 1.0 for stiff clay. So if in the problem, if it is mentioned that it is a soft clay, so directly we need to take alpha is equal to 1. It will not be given in the problem. It is if it is soft clay, so by default we can take alpha is equal to 1. Suppose if it is mentioned in the problem, it is a stiff clay, then we can they will give the number alpha value in the problem. Then we can take from the problem in the place of alpha. So Qu is equal to Qb plus Qs and Qu is equal to AB into Fp and Qs is equal to As into Fs. So Qu is equal to pi d square by 4 into C into Nc plus pi dl into alpha into C. It is for circular foundation. So for square pile, so the area of the pile at the bottom equal to B into B into CNC. CNC means bearing capacity side of the base plus 4b into L, 4b into L and alpha into C. 4b into L is the surface area of the pile, alpha into C is the shear resistance of the pile surface. So for rectangular pile, so the area is B into thickness into C and C plus 2 into T plus B. For rectangular, it is T plus B into alpha into C. So ultimate load carrying capacity, you know that. Next we need to calculate the safe load. The safe load is equal to ultimate load divided by factor of safety. Suppose if I take 100 kgs, so more than 100 kgs, I cannot bear any more load. That is the maximum capacity of a mine without any failure. So an engineer should not place the maximum load on the structure. That's why we need to take some factor of safety. So 75 kgs if you put on the pile, then it is called as safe load. So the capacitor pile is 100 kgs, but we need to put 75 kgs. That's why it is in safe condition. The safe load is equal to ultimate load carrying capacity divided by factor of safety. So Q is equal to QB plus QS. This formula is applicable for file having combined end bearing and skin resistance. That is for sandy soils. So for sandy soils, the pile can develop a friction and also the pile can rest on the hard stratum. That's why for combined end bearing QB and skin resistance QS, we use this formula. Suppose for an end-bearing pile only, sometimes piles passes through the water. In such a case, pile have only end-bearing, hence second term is negligible. So in the case of water, the friction between water and pile is nil. So that's why the second term becomes negligible. So ultimate load carrying capacity equal to the load carried by bottom tip of the pile. So Q is equal to pi d square by 4 into CNC. So for soft clays, also the skin resistance is ignored. In the case of soft clays, so there is no friction between soil and pile. That's why it is negligible. So for soft clays also, only we will calculate the end bearing and we will neglect the skin friction of the soil. So for friction pile, so sometimes hard stratum exists at greater depths. In such a case, pile cannot penetrate through the entire weak soil. Hence, the pile transfers through skin friction only. So such piles are called as floating piles or friction piles. So sometimes hard stratum exists at greater depths. In such a case, it is not economical to extend the pile up to the hard stratum. In such a case, we will insert a pile up to certain depth only. Here, the entire load applied on the pile can be taken by the friction between the pile and the soil. So such a piles are look like floating in soil. That's what is called as floating piles. The entire load is taken by friction and it is called as friction pile. So example, stiff clay soil. Here the first term is absent because the pile is not rest on hard stratum. The second term only present. Q is equal to Qs. So Qs is equal to Fs into As. As is known as surface area pi d into L, and Fs is known as shear strength of the pile surface alpha into C. So if you take a problem, a pile is driven in a uniform clay of large depth. That means the length of the pile is 6 meters. You can see in the figure. So the clay has an unconfined compressive strength of 0.9 kg per centimeter square. So UCC value is given. So we need cohesion. Cohesion equal to half of unconfined compressive strength. So half of 0.90. So the pile is 30 centimeter diameter. The pile has 30 centimeter diameter. That means 0.3 meters diameter and 6 meters long. Determine the safe load carrying capacity of the pile. Assuming a factor of safety of 3, assume adhesion factor as 0.70. So alpha value is given, and diameter of the pile, length of the pile also given. Next UCC value also given. So here, if you see the data, diameter of the pile equal to 30 centimeters, that is 0.3 meters. UCC value equal to 0.90. Cohesion equal to half of UCC, 0.90 by 2, that is 0.45 kg per centimeter square. So alpha value is given in the problem, 0.70. Factor of safety equal to 3.0. It is also given in the problem. So here NC, the bearing capacity of factor for clay soils. So it may not be given in the problem. Sometimes may be given and sometimes it may not be given. So the standard value for clay is NC equal to 9. So it is a clay soil and circular pile. So for circular pile, ultimate bearing capacity equal to AB into CNC plus AS into alpha into C. So this is the final formula. So Q is equal to D value equal to 0.3 pi d square by 4 into C value equal to 0.45 into NC value equal to 9.0. So it is kg per centimeter square. That's why it is multiplied with a factor of 10 power 4. Now to convert to into kg per meter square. So next second term pi into d 0.3 and the length of the pile 6 into adhesion factor 0.70 and cohesion equal to 0.45 kg per centimeter square. You have to convert it into kg per meter square. It is multiplied with 10 power 4. So ultimate bearing capacity equal to, so 2862.776 plus 17,812.83. So ultimately bearing capacity equal to 20.675 10 cubic kg. So it is equal to 20.675 tons. Safe load is equal to ultimate load carrying capacity divided by factor of safety. So 20.675 divided by 3 equal to 6.881 tons. So this is a layered soil. So model 2 layered soil. To determine the safe capacity of a 0.5 meters diameter and 6 meters long cast in situ pile in stiff clays, having variation of undrained shear strength as shown in figure. So take alpha equal to 0.45, factor of safety equal to 2.0 and NC value equal to 9.0. So ultimate load carrying capacity, we have the formula AB into CNC. It is a circular pile plus pi dl into alpha into C. So Q is equal to pi d square by 4 into CNC. So diameter of the pile equal to 0.5 meters. So pi into 0.5 square by 4 into C value 55 into NC value standard 9. So here the cohesion is varies from top layer to bottom layer. That's why we need to find out the skin friction layer by layer. So first layer is limited to up to top 1 meters. So pi dl into alpha into C. Pi into 0.5 into length of the pile is 1 and alpha equal to 0.45 into 50. Here cohesion top layer is 50. So second pair for second layer, the length of the pile is 2 meters. Pi into 0.5 into 2 into 0.45 into 60. So the third layer, pi into 0.5 into, that means pi into d, diameter of the pile is 0.5 into length of the pile is 3 meters into 0.45 into 35. 0.45 means it is adhesion factor 0.45 into the cohesion in the last layer equal to 55. That's why here it consists of layered soil. That's why we need to find out the skin friction by layer. The ultimate load carrying capacity here is 97.19 plus 35.3 plus 91.8. The total ultimate load carrying capacity equal to 341 kilonewtons. Safe load is equal to ultimate load divided by factor of safety. Factor of safety in the problem is 2.0. So safe load equal to 341 by 2 equal to 170 kilonewtons. So with this I have completed the uh, pile capacity in the case of clay soils. So tomorrow I am going to discuss pile capacity in the case of sandy soils and group capacity of the piles. Thank you so much for your patient for attending my online class. Thank you so much. So we will meet in tomorrow class.